Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we'll be looking at an introduction to differentiation, and in particular, how you differentiate x to any power. Now, in the last lesson, we showed that the gradient of the curve y equals x cubed minus x squared minus 6x was equal to this. So this equation would allow you to work out the gradient at any point on the curve. We'll just have a look at some language to do with all of this. We could have written that if y is equal to that function, then dy by dx is equal to this. Now, dy by dx means differentiate the function y with respect to the variable x. And whenever you find dy by dx, you are finding the gradient of the curve. So if a question is ever asking you to find a gradient, dy by dx is what needs to be in the back of your mind. Dy by dx is the gradient. We could have written that in function language, and f of x would be equal to this. In function language, the way you write down the differential, dy by dx, is f dashed of x. So that dash there means we've got the differential of the function f of x with respect to x. Now, by the same method that we used in the last lesson, it is possible to show, in general, that if y is equal to x to any power, if I differentiate y, what I have to do is multiply by the power and then reduce the power by 1. Or in function language, exactly the same thing. If I want to differentiate the function with respect to x, I multiply by the power and reduce the power by 1. If I've got a constant in front of x to the n, it makes no difference. I still multiply by the power, reduce the power by 1. And same thing in function language. Okay, let's have a look at how this works out in practice. So we've got a very long function here, but when you differentiate it, you just take it one term at a time. Now the 9x and the minus 5, you need to think a little bit about those. But I'll let you have a go at this yourself first. So pause the video, have a go, and then come back to me again when you're ready. Okay, let's have a look. Now, this formula really requires you to know the power of x for whatever you have. And for these two terms, no power of x is written down. So it just helps, either if you're thinking in your head or you actually write down. These three terms I haven't changed at all. 9x means 9x to the power of 1. And more subtle than that, if you've got a constant, minus 5, it's minus 5 times by x to the power of 0, because anything to the power of 0 is 1. Now, normally you don't need to worry about that, but when you're differentiating, you do, and we'll see now why. So we'll take it one term at a time. Differentiating the x to the 4, times by the 4, reduce the power by 1. That'll give us 4x cubed. Differentiating the 2x cubed, we'll get 3 times 2 is 6, reduce the power by 1. Differentiating the 7x squared, 2 times 7 gives us 14, reduce the power by 1. X is x to the power of 1. And then this becomes slightly easier now that we've written it in this form. So we do 1 times 9 is 9, times by x, and then we reduce the power by 1. So we get 9x to the power of 0. And here, we times by 0. So we get 0 times by this term. Now, the moment you times by 0, you are just going to get 0. So we don't really need to worry about anything else. The only bit of tidying up I need to do is really with this term here, where I've got 9x to the power of 0. Anything to the power of 0 is 1. So 9x to the power of 0 is just 9 times 1. So the differential is this. And this would be the final answer. Now, these last two terms were important. So note, first of all, if you just have some number times by x, like we had 9x in the question, when you differentiate that, you just get the number, you just get a. And the reason for that is because you get this x to the power of 0, which is 1. But you just need to remember the rule. If you've got y equals ax, when you differentiate it, you get a. And if y is a constant, doesn't matter whether it's minus 5, 10, or any number, when you differentiate a constant, you always have this business where you'd be multiplying by 0. So you just get 0 for the answer. So if you differentiate a constant, you will always get 0. Okay, example 2. Same idea, but this time using function language. So we're told what f of x is, and we're asked to work out the differential f dashed of x. I'll let you have a go. Pause the video, come back to me again when you're ready. Okay, let's have a look at this. Now, a bit like the last question, before we start, we really want to have everything written in this sort of form. So x to the power of something. Now, these two terms here are not written in that form. So it does help if we just rewrite them in that form. So we don't do anything with the first two terms, but 1 over x squared, that's x to the power of minus 2. Minus 4 over x, that's minus 4x to the power of minus 1. It's very important that you're good at doing these sort of manipulations when you do differentiation. We won't worry about the 7/8. We know that when we differentiate that, we'll get 0. But anyway, now we'll differentiate it one term at a time. So first of all, differentiating the half x cubed, we'll get 3 times by a half, which gives us 3 over 2. The power of x goes down by 1. Differentiating this term, we'll get 2 times 5 over 2, which is 10 over 2, which simplifies to minus 5. Again, the power goes down by 1. For this term, we'll multiply by the power. So we multiply by minus 2, which is why we get the minus here. And it'll be minus 2x. The power goes down by 1. Now, if you take away 1 from minus 2, it'll go down to minus 3. This term here, we'll be doing minus 1 times by the minus 4 when we multiply by the power. That's why we get the plus, which gives us 4x. Again, the power goes down by 1. If you take away 1 from minus 1, it goes down to minus 2. This last term here is a constant. If you differentiate a constant, you get 0. And then finally, you could tidy up the answer. This line is correct, but if you wanted to tidy things up, and it's certainly important that you're able to, these two terms we wouldn't do anything with. 2x to the minus 3 means 2 over x cubed. 4x to the minus 2 means 4 over x squared. And that would be the answer. Okay, example 3 has a lot more work that you need to do before you can actually do the differentiation. Comes back to the same issue we had on the last question. We can only differentiate something of this form. So we do need either x to the power of something or a constant times by x to the power of something. And we don't have that at the moment. So a number of these terms need to be simplified so that they are written in either this form or this form. I'll let you have a go at doing that. So pause the video, try and work your way through this, and then come back to me when you're ready. Okay, so the hard work is really just tidying things up at the start. X to the 4 times by x to the 3, that will give me x to the 7. X to the 5 divided by x squared, that simplifies to x cubed. X to the power of 1 divided by x to the power of 6, you do 1 to minus the 6, which gives me x to the power of minus 5. Root x, we'll write that as x to the power of a half, because then it's in this form. And minus 4 divided by root x will be minus 4x to the minus, because we've got a reciprocal, and a half because we've got square root. So that's the important part of this question, really, being able to convert all of these things into the standard form that we are able to differentiate. From then on, we're just applying the rule as normal, times by the power, and then reduce the power by 1. So that'll give us 7 times by x, and reducing the power by 1 takes it down to 6. Then we'll get minus 3x when we times by the power and reduce the power to 2. X to the minus 5, so we'll times by minus 5, that's why we get the minus here, and then the power will go down by 1 to minus 6. Timesing by a half here, we'll get minus a half times by x, and then we'll need to do a half take away 1. Half take away 1 is minus a half. And then here, when we multiply by the power, we've got a minus a half times by minus 4. Minus and minus is a plus, which is why we have a plus here. A half of 4 is 2. So we'll have 2x, and then this power needs to go down by 1. Minus a half take away 1 takes us down to minus 3 over 2. That is the differentiation done. But a bit as with the last question, these last three terms you could tidy up. You don't have to, but it is important that you're able to do so. So we won't do anything with the first two terms. Minus x to the power of minus 6 becomes 1 over x to the power of 6. Here we've got two things. We've got the minus in front of the power, which means we'll have the reciprocal, 1 over x. Half means square root. Also, we've got this fraction on the front here. Now, the number on the bottom of the fraction stays on the bottom of the fraction. Minus is what brings the x down, and half means we've got square root x. And then this last term, this time the 2 is on the top, so the 2 will stay on the top of the fraction in a moment. Minus is what takes the x down to the bottom of the fraction. 3 and 2, we could leave it as that. The 3 means cubed, the 2 means square root. So one option would be to write it as 2 divided by the square root of x cubed. Okay, last example. We've returned to function language. And in this question, the function is 5x squared minus 2x plus 5. First of all, we're asked to work out the gradient at the point 1, 8. That means you'll need to differentiate this and then substitute in x equals 1. We're asked to find the coordinates of the point where the gradient is minus 2. So we'll differentiate this, get f dashed of x, and then create an equation. When does it equal minus 2? And then last of all, we're asked to find the gradient at the points where the curve intersects the straight line y equals 2x plus 6. Now we'll need to solve these two equations simultaneously to find the two intersection points, and then substitute the x values into f dashed of x to find the gradients. Quite a lot going on there. I'll let you have a go at this yourself first. Pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look at this. So part 1 asks us to find the gradient of the curve at the point 1, 8. That means we need to differentiate it. The gradient of f of x is f dashed of x. That's the way you'd write it down. F dashed of x, we do 2 times 5 is 10. So that gives us 10x when the power goes down by 1. And when we differentiate minus 2x, that gives us minus 2. It was one of the standard ones we looked at just now. If you weren't sure, then it would be minus 2x to the power of 1. So you do 1 times the minus 2 gives you minus 2. Then you get x to the power of 0. X to the power of 0 is 1, which is why that is minus 2. Now we've been asked to find the gradient at the point 1, 8. The significant value there is the x value. X is 1. So we just need to substitute x equals 1 into this equation for the gradient. F dashed of x is the gradient. So that'll give us 10 times by 1, take away 2, which gives us a gradient of 8. Part 2 asks us to find the coordinates of the point where the gradient is minus 2. If the gradient is minus 2, that means that f dashed of x has to equal minus 2. Now we worked out f dashed of x just now. It's equal to 10x minus 2. And we want to know when that is equal to minus 2. So when does 10x minus 2 equal minus 2? When does the gradient equal minus 2? Solving that gives us 10x is equal to 0, which means it's at the point x equals 0 that the gradient is minus 2. Those aren't the coordinates of the point. That would just be the x value. To find the coordinates, we'd need to substitute x equals 0 back into here, and we get 0 minus 0 plus 5. And that will give us the coordinate 0, 5. Part 3 asks us to find the gradient of y equals f of x at the point, or the points, where the curve meets the line y equals 2x plus 6. So we've got a quadratic curve, which is going to intersect this straight line at 2 points. The first thing we need to do is find those 2 points, which means solving these two equations simultaneously. And that'll give us 5x squared minus 2x plus 5 is equal to 2x plus 6. That gives us 5x squared minus 4x minus 1 equals 0. And that quadratic does factorize into 2 brackets. So we'll get 2 solutions for x, either x equals 1 or x equals minus a fifth. Now we need to find the gradient of those 2 points. Well, the gradient, as we found before, is equal to 10x minus 2 when we differentiate the function. All we have to do now is substitute x equals 1 into that, which gives us a gradient of 8, and substitute x equals minus a fifth into that, which gives us a gradient of minus 3. And that would be the answer. Okay, that gets us to the end of this lesson. And if you have the textbook, there are now 3 exercises that you should be able to do. Exercises 8C, 8D, and 8E. Thank you very much for listening, and cheerio.